3.4.2 SAR ADC R2R Ladder DAC. This here is the circuit for the second part of this SAR ADC build. It includes an LF398, an LM393 chip, which is the dual comparator and the sample and hold, as well as a R2R ladder DAC here with the R and 2R resistors controlled by the switch bank. So first thing to note is that this circuit uses a positive and a negative 9 volts for a total range of 18 volts. That's because this LF398 sample and hold chip needs a positive and negative 9 volts. This is the only part of the circuit that requires 9 volts. The rest of it is 5 volts. So first of all, we take a variable analog voltage on this LF398. So right now I have a potentiometer wired to ground and power, and we can get a swing of voltages here from all the way to 0 all up to 9 volts. But for this example, let's go around 4. So we have about 4 volts on this input pin of the LF398. When I press this button, which is connected to the logic pin, which would normally be controlled by the clock and the chip, and so it can cycle very quickly, but right now it's a button. It's going to be pulled high, as you can see here. And when I press it, the voltage here is going to go to this output pin. So if we check the output pin right now, we have 3.3 volts, it looks like. Or sorry, 0.3 volts. So very, very low. If I press this button, the input voltage, which remember is 4 volts, is going to go to this output. So I press that, and we can see up to 4 volts. Now, you're going to see this steadily decreasing. And that's because the voltage here is stored in this capacitor, this 1 nanofarad capacitor. It's a very small capacitor, but it doesn't need to be too large because the circuit cycles very quickly. As seen in the last video, the clock's very quick. So the idea is that you're constantly cycling. So if I press this, we'll get back up to 4 volts. Every time you press it, it is taking the input voltage, grounding this resistor so it gets rid of the previous voltage, like discharging it, and then filling it back up with the new voltage. So this output here goes to the input, the positive input of the comparator. We're just using the top comparator for this project, although it does have two. So the positive input of the top comparator. If the positive input of the top comparator is greater than the voltage on the negative input, the output here is going to be high. Okay, so right now, the positive input is higher than the negative input, which is why the LED is on. Now let's check out what is going on the negative input. So the negative input right now is controlled by our ladder DAC. Right now, you see this first bit is on, and we have 3 volts on the DAC. So if we press the button, we are comparing here 4 volts to 3 volts. If I flip this second bit here, if I flip the second bit here, you'll see that the DAC is now reading 5.82 volts. If I press it, no matter how much I press it, it's going to be 4 volts on the positive compared to the 5.8 volts on the negative. So since the negative is higher, it's going to be an output of a low, and the LED doesn't turn on. The whole DAC uses, this whole SAR ADC build uses this DAC to quickly compare voltages on the input and this DAC to see where the voltage currently lies. And it does this operation very fast, as seen with the clock in the previous circuit. That's the basis of this circuit. So I thank you all for watching, and I hope you have a great day.